Hello grade 10s, welcome back again for a second video. I hope the first one was clear enough. With simultaneous equations, two methods, two unknowns. Yesterday we did the elimination method and today we're going to do substitution method. But before we head into the method, I just want to point out something about simultaneous equations. So if we look at the board here, we've got our two equations again, equation A and equation B. Remember, there's only going to be one solution, one x and one y, that satisfies both of those equations, that makes them true. Now, if we take these equations and we graph them, remember anything in maths can always be represented graphically. So if we look at this equation here, that, if I represent it graphically, is a straight line A here. Remember, you have your x-intercept and your y-intercept. Then if we look at equation B, which is here, that represented graphically is the red line here with your x-intercept and your y-intercept. So now if we draw the two graphs, remember there's only one x and one y that satisfies both. Now if you look at these two straight lines, where do you think that is? It's going to be there, right? It's going to be the point of intersection. It's going to be at that point where a single x is equal to a single x on each line. By the way, this was the answer to the simultaneous equations. So x equals 2 would be more or less there, and y equals minus 1 would be more or less there. So if we take simultaneous equations and we represent them graphically, then the solution for x and y is actually the point of intersection between the two graphs, because at that point they're equal to each other. And that's just tying it up into graphs. If we take it a step further, it begs the question, are there going to be any values where there would be more than one solution for x and solution for y? So if we think about straight lines, no, I don't think so. Whenever you have two straight line equations, there's only going to be one point of intersection, never more than one. But what about saying there's no points of intersection of two straight lines? So if we think about it, would there ever be a scenario where we had two lines, two equations, but there were no x's and y's that satisfied those two equations? In other words, there was no real solution. Would there ever be a case like that? If you think about two lines, what about if we have two lines that do this? In other words, two straight lines that are parallel. Would they ever cut each other? No. So therefore there would be no solution in that particular case there. So there's only either going to be one x, one y, one point of intersection, or there's going to be a scenario where there's no real solution. Okay. That's all. Now if you can watch the next little video, which just explains the second method, the substitution method, and then after that there will be notes on iTunes U. Bye.